So now we're going to talk about Ernest Rutherford's gold foil experiment. And what he was setting out to do was prove that the plum pudding model of the atom was correct. Now the plum pudding model described the atom as a sphere with a positive charge, evenly distributed, as well as the mass of it being evenly distributed. And then they had already known about those little tiny electrons from J.J. Thomson that would be floating about. What he has for a setup is he has a lead box to prevent radiation from just going everywhere, but inside that he had a source of alpha particles, essentially uranium. Alpha particles are small, positively charged radioactive particles that when they travel, they have a decent amount of momentum with them, and they'll be repelled by positive things. But because they travel at 1/10 the speed of light, they're expecting that if they put a sheet of gold foil that's really thin, only like 40 atoms thick, I didn't really know that's how thick it was, but that's essentially how thin it was, you could see through it. What they expected to happen was those particles would blow right through it, and they would hit this phosphorescent screen that would give off little flashes of light wherever they hit. So he was going to just, if everything went through, it proved the plum pudding model of the atom to be accurate. But what happened was, and he described it as it was like he was firing a 12-inch shotgun shell at a piece of tissue paper and having it bounce back at him, what he got was this. Most went through, but many scattered off at wide angles. Some even bounced right back at the source. So what this implied is there had to be a dense region of mass and charge. So they basically understood now that there had to be a nucleus within the atoms that was capable of exerting a sufficient force to make them bounce backwards, which also implies that the atom is mostly empty space, because otherwise you wouldn't have the vast majority of the alpha particles passing through. And in fact, when you're comparing the size of an atom, it's like if you have a golf ball in the middle of a soccer stadium, the outer edge of the stadium would be where the electrons are, and the golf ball would represent the nucleus. So it's 99.99% empty space, and they've discovered the nucleus, and in the next video we're going to start talking about the components of the nucleus.